Hey guys, so let's continue our course with our next topic, ADT and memory allocation. At the very first, what is ADT? ADT means abstract data type. An abstract data type itself means not in details, means there is some part which is hidden. For example, imagine if you want to drive a car, what you should know? You should know the use of accelerators, use of brakes, and also controlling the steering wheel like that. And which knowledge is not required is that how on pressing accelerator the speed is increasing or the inner mechanism of the car. You don't need to know it, right? Likewise, editing means to hide how the operation is performed on the data. Like here, you are driving car, but you don't know the inner mechanism of the car, right? This is typically used for doing operations on data like add data, delete data, searching data, retrieving a specific data in data collection. Let's move ahead. Moving to the next, an ADT is composed of a data collection and set of operations on that data. These are actually the parts of an ADT. Let's have a quick example. Let's assume I told you to build a PC. Okay, actually it's not possible to everyone, but just assume that I told you to build a PC. And what I challenge you that my PC should have streaming and gaming. That's all about the minimum functions which I required, and I told you. Then I gave a blueprint to build a PC. What blueprint is? It's just like an outline. And in that blueprint, there is a certain list of components which I require. That is RAM, graphic card, processor, motherboard, etc. And these are what components where operations is done. Which operations? Operations to give us a quality streaming and gaming. So this is how ADT also works. What ADT is, ADT acts like a blueprint. Here also, RAM, graphic card, processor, motherboard, these all were components. I didn't ask you that which version of graphic card you are referring, which certain typical type of processor you are referring, which company did you refer to make such components and to take these components to make PC. I just ask you that my minimum functions are streaming and gaming. I don't care which kind of graphic card you are using or what. I just want a quality streaming and gaming. Likewise, ADT also acts like a blueprint where certain kind of functions are performed. Like in ADT, I firstly told you to let's have some code in which maximum, minimum, search, insert, append, these functions are performed. And these are known as minimal functionality requirement. I just told you to do such kind of program or to make such kind of code in which maximum, minimum, search, insert, append, these functions are performed. But I didn't ask you through which data structure you are performing these functions. You are performing certain tasks. You could use linked lists, you could use arrays for storing some data on which operations are done. And this minimal functionality requirement is satisfied. But I didn't ask. I just told you to code. That's what ADT is like. ADT doesn't ask anything. It just gives you a blueprint to perform certain tasks. Let's see the operations on ADT. ADT natural number is. means what operations could be done on natural number. But listen to me very carefully. I'm not asking anything about which data structure are you using for performing certain type of task on it. Okay. Objects. An ordered subrange of the integer starting at 0 and ending at the maximum integer. Okay. This is int max on the computer. Functions. Objects I have defined that it will be my natural numbers. Okay, objects will be natural numbers and ordered subrange of integers which are starting from 0 and ending at maximum integer which you want. Okay, so and functions, the functions which we are going to perform belong to natural numbers. True and false belongs to Boolean algebra because true means 1 and false means 0, where plus, minus, less than, equal to are the usual operations. What does it mean? Addition, subtraction, comparison of which one is greater and which one is minimum, or sorry, which one is smaller, and equal to are they same or not for checking it. These operations are usual. Natural number 0. This is natural number 0. So what does this Boolean is 0x is doing? This is a function. What it is doing? It is, I am giving a condition that if x means if there is any number, then return false. Else return true. Means if this condition gets false, then return true. Likewise, Boolean equals to means there are two natural numbers we are taking in considerations, and if they are equal then return true, else return false. This is what Boolean equal x comma y function is doing actually. The next one is natural number successor, which checks if the number is the maximum integer we entered, then return x. Otherwise, add 1 to it. The next one is natural number add. Means if whatever maximum integer we were taking in consideration, if the addition of two numbers is less than that maximum integer, then return x plus y, else return whatever maximum integer we have stored there. Natural number subtract. Likewise only, as like addition worked, likewise subtraction works. If x is less than y, then return 0. But if this condition fails, then return the subtraction, whatever subtraction of this x minus y is. Moving to the next, let's see what is memory allocation is actually. So, memory allocation is a process by which computer programs and services are assigned with physical or virtual memory space. Memory allocation is primarily a computer hardware operation but is managed through operating system and software applications. So, this is very typical definition, but in easy terms, I would like to tell you that memory allocation is a process in which memory is allocated to pointer. Why pointer? Because pointer holds the addresses of another variables. That's why memory is allocated to pointer. Memory allocation has two core types. The first one is static memory allocation, in which the program is allocated memory at compile time. Compile time is the time when program is in compilation mode. Dynamic memory allocation. In this, programs are allocated with memory at runtime. Runtime could also be called as execution time, when program is in execution mode. So, what is the purpose of using dynamic memory allocation? In easy terms, let's have a look on this example. Here, since C is a structured language, it has some fixed rules for programming, and one of it including changing the size of an array. An array is a collection of items stored at contiguous memory allocation like this. So as it can be seen that the length or size of array is 9, right? Here the array length is 9. But what if there is a requirement to change this length? For example, let's take a situation. If there is a situation where only 5 elements are needed to be entered in this array, right? So in this case, the remaining 4 indices are just wasting memory in this array. So there is a requirement to lessen the length or size of the array from 9 to 5. Because here the size is 9, right? Array length is 9, but only 5. Suppose we need to insert only these 5 elements. So these four memory blocks are just wasting. So we need to resize it. Or take another situation like in this, there is a array of 9 elements with all 9 indices filled, but there is a need to enter 3 more elements in this array. In this case, 3 indices more are required. So the length or size of the array needs to be changed from 9 to 12. This procedure is referred to as dynamic memory allocation in C. Therefore, dynamic memory allocation can be defined as the procedure in which the size of a data structure like array is changed during the runtime. Moving to the next, let's study about static and dynamic memory allocation. The very first is static memory allocation, and here are some points. So let's discuss them one by one. The very first is memory is allocated before the execution of the program begins. Means memory is allocated during compilation. No memory allocation or deallocation actions are performed during execution because variables remain permanently allocated here. Once the size of array is defined, you can't change it. Implemented using stacks and heap. Actually, this part we are going to discuss in further lectures. So let it be. And the next point is pointer is needed to accessing variables. Yes, because pointer holds the address of variables, so it is needed to access variables. Faster execution than dynamic. It has very fast execution as compared to dynamic. More memory space required. This you can say it is a disadvantage of static memory allocation because once variables are allocated with the memory, it is being permanently allocated and you can't resize once allocated memory. That's why more memory space is required here. The next one is dynamic memory allocation, and here are some points. So dynamic is totally opposite of static memory allocation. Here memory is allocated permanently, whereas in dynamic memory allocation, memory is allocated temporarily. So memory is allocated during the execution of the program, means during runtime. Memory bindings are established and destroyed during the execution. Yes, because in dynamic memory allocation, the memory is allocated temporarily. That's why it is established at the same time and destroyed at the same time. You can do this both actions here. So allocated only when the program unit is active, that is during runtime. Implemented using data segments. There is no need of dynamically allocated pointers here. It has lower execution than static and it has less memory space required, as you can resize the size of array as per your conditions, as per your situations. Moving to the next. So there are 4 major functions of dynamic memory functions which you can perform and which helps you to resize the size of array or to free up the memory. So the first one is malloc. It allocates the specified number of bytes. Calloc. It allocates the specified number of bytes and initializes to 0. Realloc. It increases or decreases the size of specified block of memory. Free. It deallocates the memory, returns specified block of memory back to the system. The very first function is malloc function, and here is the syntax of malloc function. So let's discuss how malloc function works. Syntax says cast type asterisk malloc size t size will allocate the memory to pointer. So size t size stands for specified size. How malloc works? It specifies in bytes the size of the area you want to reserve the argument. Means here you will tell the malloc how much size you want to allocate. Cast type. Cast type is used to convert one data type into another data type. Here you will mention the type of data. Let's take an example. Pointer equals to int asterisk malloc 12 asterisk size of int. What it will do? It will create a pointer and allocate the memory to it. How much memory? Here you have specified the memory 12 into size of int. What is size of int? It is 4. Size of int is 4. So 12 into 4, 48. So a large 48 bytes of block is dynamically allocated to pointer. But wait. Will you think what does this 48 bytes of block will contain in it? It will contain of garbage values. Means each block of this memory will be initialized with garbage values. This is the main difference between other function and malloc function. It initializes each block with garbage value. So this is the key point to remember. Next function is calloc function, and here is the syntax of calloc function. Cast type asterisk calloc n comma size of elements. Size of elements stands for the specified size and n stands for the number of elements you want to store in it. So how does calloc works? This function returns a pointer to the allocated memory or null if the request failed. Means calloc also works in the same manner as malloc works. The only difference is it initializes each memory block with 0. Let's take an example. Pointer equals to float asterisk calloc 12 comma size of float. So what it will do? It will create a pointer which will be allocated some memory. But how much bytes of memory? 12. You want to store 12 float elements, right? 12 float numbers you want to store, and size of each float is 4 bytes. So 12 into 4, 48 bytes. So 48 bytes of block is dynamically allocated to pointer. But it will initialize each block with 0 value. Always remember that this is the major difference between malloc and calloc. Malloc initializes each block with garbage value, whereas calloc initializes each block with 0 value. So the key point is 0 value. The next one is realloc. Here is the syntax of realloc. Cast type asterisk realloc pointer comma new size. Now what realloc do is, realloc attempts to resize the memory block pointed to by pointer that was previously allocated with a call to malloc or calloc. For example, int asterisk pointer equals to int star malloc 5 asterisk size of int. Means here this pointer is different. Why different? Okay, let's understand it by example. Firstly, you allocated some memory to pointer. How much memory? First pointer is created and in it 20 bytes of memory is allocated. How? 5 into size of int, which is 4. That is 20 bytes of memory is allocated to pointer. Now I am performing realloc. Suddenly I came to know that instead of 5 elements, 5 variables, I wanted to store 10 variables. Then what in that situation you will do is you will deal with realloc function. Realloc will resize the memory block pointed to by pointer. Now, here this pointer is which pointer? The pointer which is previously allocated by using malloc. So this is the pointer which we have mentioned here. And after reallocating, what will be its size? 10 into size of int, that is 4. So here 40 bytes of memory will be the size of the blocks allocated to it. This is how realloc works. The next one is free function. So free method in C is used to dynamically deallocate the memory. Dynamically deallocating the memory means freeing up the memory. The memory allocated using function malloc and calloc is not deallocated on their own, and that's why free method is used whenever the dynamic memory allocation takes place. Let's have one example on it. Pointer equals to float asterisk calloc 12, size of float. Here again we are allocating memory to pointer using calloc, and the size of memory would be 48 bytes of memory. Now what I am doing is, once I am allocating the memory to pointer, now a situation came that I don't want this memory and I want to free it up, because there is no use of allocated memory in my file. I found it, and that's why I want to free up it. So what I will do, I will just simply use this syntax free pointer, means I'm telling to the function that please free my pointer, I don't need it. And what it will do, the pointer will be freed up and the memory would be released. So this is how the free function works. Hope you got it, all the three functions very perfectly. So thank you guys, and see you in the next class.